Hi, everybody. Welcome to another conversation today, talking about additive manufacturing, focused on injection molding, though. We're going to have a little chat about a company called Krauss Maffei. And today I have Michael Helneder here to talk about the company. And Michael is the head of additive manufacturing customer success there. So, Michael, welcome. How you doing?
Hi, Adam. Thank you for having me.
Yeah, good times. I know we've had some good conversation prior to this and lots going on with your company and what's been happening with additive. It's exciting to see when a company adopts additive manufacturing like you have for certain reasons that make sense. Talking about injection molding, you guys have been going at it for 180 years. So you have a lot of experience and you bring a lot of background into why this particular process now is a viable technology that you're using. So get to talk about that a little bit and excited about that.
Yeah, it starts almost over 10 years ago, more as a technology we used inside for spare parts, checks and fixtures, some other parts. We learned much about the systems and the technology, and I was always focusing on new business models and what our customers or the customers in the plastic processing and plastic part manufacturing are needed and make a fit to injection molding. And the most and almost every customer is coming from the industrial environment, material production with high automation. This is what we don't saw at this time is happen in additive manufacturing. So we decided to develop our own products and to go in this environment of industrialization for our customers.
Makes sense. And when you say you actually have your own machines you use for the customers when you develop the parts for the customers inside of additive manufacturing, so you work with different kind of solutions inside of industries and walk them through their options, right? And definitely have some different options inside of AM, and that's why you've included it in your catalog of options for the customer. Talk a little bit about that and why injection molding itself looked at additive as another solution. You talked about the digital side of it and also the ability to automate. And I know that's big with Krauss Maffei and what you've done over the years with automation inside of injection molding. So it ties right into the next level of digital transformation from the outside. But how does that look from inside the company?
So it's absolutely necessary to go with an automation in injection molding and the other technology, because you always talk about these high volume of parts. It's not like additive manufacturing where you put 5 parts out of it. They are falling 50 parts from one injection, and therefore you need these high speed and high industrialized automation behind it. And this is something we have inside. So beside our other technologies, we have our own automatization. And this department, we are working very close to automatization, our additive manufacturing systems, to bring this solution and this industrial automatization into additive manufacturing.
Nice. So talk about the technology a bit, because I know you use a couple different technologies there as far as additive manufacturing goes. Can you let us know what technologies are being used there?
At Krauss Maffei, the main technologies I can tell is injection molding, for sure. We have extrusion technologies like an endless pipe, we extrude something. Another technology is reaction processing.
Yeah.
It's like for big car parts or something else. It's working with a resin and big molds. And yeah, for sure, additive manufacturing as the fourth technology, really new. And besides digital solutions, where we have our own digital department and products and the service as well.
Yeah, makes sense. And the two AM technologies you're using are both, you're using the SLA with the resins, correct? Yeah, and the other technology that you have is which one?
It's a granule based large scale 3D printer. So it's two completely different technologies
Yeah.
and system
Yeah.
size, and goes in complete different directions. I think the power print it's called, so the granule based is working with an extrusion unit. So we took all our knowledge about extruder and extrusion plastic granules inside this system, put an automation beside, and developed this large scale printer. And it's more for new markets, as well as injection molding, extrusion molding markets like pipe and fitting, molds, for examples. Packaging solutions is another field. The key about this system is high industrialized system. So we have output rates more than 30 kilogram per hour, and a build volume 10 cubic meter, so 2.5 to
Right.
2
Large
meter
volume. Yeah,
two
it's nice.
meter height. So that's really large.
Yeah.
And it's a closed system, and it's something we learned when you look in the past. You saw these desktop printer that was open housing, no heated platform. That's something you can start with, but not go in high quality parts. When you look at this time on desktop 3D printers, they are completely housed. There's digital inside, and this is something we transferred in large scale. So everything you know as an home use of 3D printing, heated build plates, extrusion control, flow control, heat resistant enclosure. This is what we transferred as an development in the large scale to produce larger parts in high quality.
Yeah, it is. I mean, that's really that's the pellet system
Yeah.
for industrial machine
Yeah.
design. Yeah, that's very interesting. I've seen some of that around, and you're talking about doing it larger, but also it's enclosed, so you have a little bit way of dealing with the materials differently. Is that what I'm hearing? It helps
Yeah.
with the way the material is printed. And I know you have a special head, a deposition head that actually does that. So talk
Yeah.
about what the technology is doing differently. What is it that now with this particular design that actually gives you a little bit more flexibility?
You have the same problems and defects as in a smaller 3D printer. So you have warping, so that your part is popping up from the printing plate. This is something you have to heat. So you have to heat the print plates. We have 16 vacuum plates. Put our developed print plates on it, and we suck it down, heat it up. So we are sure that the part is completely sticky and flat. And at the end, you switch off the heat zones, and you can easily remove the part by crane and don't have to scratch it up from wood or other surfaces. And other big feature is the melt control. So we control the melt over the path. You have always really sharp corners. So you have no over extrusion, under extrusion, because when we slow down, we reduce the flow, and when we speed up, we give it more. Yeah, that's some key features, as well as the enclosed housing. When you go in a technical material area, like polycarbonate or polypropylene, so PP, for piping, for example, you need a enclosed housing to get always these a good thermal environment and no cold air from the sides or from the top.
Yeah, makes sense. And so a lot of what you're doing with that is the large scale used mostly for forms or tools, or what do you mostly print with these with those large scale printers?
Mostly for molds and tooling. So thermal tooling and glass fiber, carbon fiber, hand laminating tooling. So a completely new area of customers and completely new industry for Krauss Maffei. So it's not really in our home turf, when I said, and some other industries we are focusing with with our parts are in, for example, packaging, so customized pallets or handles for transport aids or something like this, and pipe and fitting for customized huge manholes and pipes, which is possible with injection molding, but you have a very long cool down phase because you inject 100 kilo in one mold, and then you have to wait maybe an hour or more to cool down the plastic, and then you put these huge piping out of the system. And there you can bring benefit with AM inside because you can change the geometry of a pipe. When I manufacture a mold for injection molding for piping, it's always the same part. And it's absolutely expensive to manufacturing these huge molds and the system as well. So this is, I think, one big case in additive manufacturing or large scale additive manufacturing, so pipes and fittings with polypropylene.
Okay. Yeah. And so when you're working, I mean, you have a lot of offerings there, obviously, to the customer. How does that typically look when they're coming to you? Is it something like, you've been working with them for a while and they want to look at different things that benefits that AM might have? So you start talking to them about that process, or is it just, part of the normal, kind of progression of what you walk your options through when you're first talking to a customer? How does that kind of come into play when you're working with your customers?
I think the first step is to understand what is the customer needed. So and that's often not really easy because you have to go in a deep talk with the customer to understand the real problem he has. Because only when we understand the real problem, we can go through projects to solve them. And that's often starts to understand the application, so the part. Is it the part for end use? Is it the part from this beginning and demonstrate or whatever? And then we go through printable design optimizations. We print the first prototype when you like, as well as a material qualification. So he brings his own material, his own 1,000 kilogram pellet to us, and we qualify this material and give him an indication if it's possible to print the parts with his material. Yeah, there are often some other solutions are like in training on additive manufacturing on large scale, on small scale, obviously depending on where we start to talk with our customers.
Yeah, because you're looking at them, you're identifying the application, and you're looking at the design optimization, and you have it all there. Then you maybe additive manufacture the part, and then the post processing that goes on, and then even delivery to the customer. You're handling all that at the company. That's part of working with Krauss Maffei, correct?
Yes, it's not only to sell the system in the market.
Right.
It's more to be sure that we sell a solution. That's, I think, the difference.
The biggest thing. Now you're talking a lot about large scale additive manufacturing, and I know you do smaller scale AM also. So, and that's the resin based printing we were talking about earlier, the SLA side of it.
Yeah.
Where does that come into play? Can you talk a little bit more about that?
SLA is the recuring process. It's very near at injection molding. So it's the materials are mimic the thermoplast materials, and you get a high quality of the part. So good surface quality is glossy surfaces. So we are very strong in the area of injection molding, and always when injection molding can't fit the batch sizes of 1,000, 100,000, or the complexity of the parts.
Oh, yeah.
There we go in with the UV or resin-based system called precision print, and focusing so it's not on the system, more on the automatization behind it. So we like to go in a high volume production of parts, so that customers starting the system, go over the weekend, came back, and you have a stack of parts produced with an automatization concept behind it.
And so what is that part of the automation? It's just the ability to move it through that part of the process. What happens on the automation side?
There at the moment one or two steps. So we have on the system on the left and on the right, like a magazine tower. So you have on the left side your empty build plate, and you load always the printer. So you load one print plate, print your build shop of different parts. The end, automatization came in, grab the build plate, and then he stack it in a other magazine tower. And after then you can go in the post processing. So that's the first step we developed and go in the market. But that's not the end. So, and you have to look that you bring post processing as well in the automatization concept. So you have one line completely automated. Is what I see, and a good customer told me he liked an additive manufacturing system where the final part is falling in a box, like injection molding.
Sure.
Inject it and it fall in a box. And this is a simple a sentence he said, but we are focusing on this vision and aiming to develop this.
Yeah, it's part of the production process. You're looking at what happens after it's done printing.
Yeah.
You have to do some post processing. Sure, you have the ability to automate and set that up for the post processing side of it and move it through its next part of the manufacturing process. It's what happens to it next, like you're saying there with the automation side. Really cool. We kind of jumped ahead a little bit of all that, but how did you get involved, or how did you just gravitate toward the AM side of it? So tell us about your journey. Where did that catch your attention, I guess I should say?
That was a long time ago. I started with 3D printing, so not at Krauss Maffei before. So I came from the technical background and production side, was in hydraulic, medical, and the aerospace sector. And in the aerospace sector at this time, a colleague at this time showed me a 3D printed component or 3D printed part. It was an IT guy. He showed me a manufactured part, what he did at home. This was the first time I was absolutely fascinated from additive manufacturing, because I thought, when he can print and produce parts, imagine what I can do at home. And after a few days, I had my own 3D printer at home. Now I have 3 in my basement.
There you go. And, so you've been bit by the bug. Yeah. Yeah.
And I at Krauss Maffei I got in additive manufacturing by chance. So I was always doing it at home and my stuff, and I started in injection molding business development.
Oh, cool.
At Krauss Maffei, and then I focused more on new business models and very strong on additive manufacturing, always with the focus, okay, what can we do, and what is the market and the customer needed in additive manufacturing. And there we had these two departments, so the in-house manufacturing with other technologies, and the business side and the strategic side. And this is how Krauss Maffei came into additive manufacturing at the end. So
yeah, no, it is really, it's another way of building that gives you some different options to do that, and you could use it on all sides of what's happening there. It sounds like in the injection molding industry, and I love to see companies taking it on and actually making it bigger than it is, because it's part of what you can actually do in different, designs and different processes that you have, and how you could benefit from it, and so it sounds like you're presenting to that customer on all levels, and that's really cool to see. It's just not somebody with a printer printing stuff. It's somebody that's giving the full solution of how you could actually improve and get better with it as you go. That's really nice. Yeah, great to learn more about the company itself. Now, what do you see as like next for Krauss Maffei, and what where you're getting the feedback from the customers? They'd like to see more of this, or hey, now that we're doing this, what's the next thing you think coming up that's more like an application or gravitation of, we're going to start doing more of this with that?
I think the most is or the biggest thing is in industrialization. Additive manufacturing came very strong from this prototyping character, and you see very less systems in the market with potential for serious production and industrialization. And this is the feedback we're getting from the customers. This is where we focusing. So the hardware industrialization, as well as digital products, as software solutions around the systems, as well as automatization. So I think the key parts of additive manufacturing, and very precise on application. So a system is not fitting every application, and don't fit in every market. So you have to be sure to get a direction on a specific application or industry.
Yeah, makes sense. Now, also, we talked about this through the whole conversation, the advantages of additive manufacturing. And, of course, you don't use it every time for every application, but there are its own advantages. You touched a little bit on the materials and how you use materials there with the customer, and find, what's beneficial for them to print with. Now, what about the other side of like recyclability, and what you look at sustainability? Does that also help the company? That, is that something that you're seeing a benefit with using AM, and part of why it's a digital option to look at materials and not waste so much material, I should say? How do you see that fitting into your processes there?
So on the large scale part, it's a big focus on recycled materials. So we have a lot of, for example, one material is made of old tires, PET sheet with old tires, or other one is with 30% post-industrial waste recycling. And we look as well on how we can go with the end parts from customers to reuse the material in an extrusion, or to regranulate this material and reuse it in our process. And this is something we are in a university project in Germany as well, focusing with our extrusion technology to go these directions. And that's I think a strategic way everybody has to go at the moment in the industry. So to focusing on waste reduction and as well as on recycling.
Yeah, it makes sense. There's a lot that you could do inside of that. And yeah, I'm glad we touched on that a bit, because it is exciting to see how that's also used and becoming more of an advantage with the AM processes, with materials. Really cool. So, wow, I think I've learned a lot about Krauss Maffei today, and exactly what's been happening there. It's exciting to see where you're going with AM, and what you're going to do next. Anything specifically you'd like to add while we do have you here?
Not specific. Was absolutely great to talking about additive manufacturing with you. I think we have this hype cycle. We completely at the bottom of this Gartner hype cycle of additive manufacturing, and I think the only way to bring additive manufacturing upwards is to talk more on honest way with the customer. So at some point, additive manufacturing makes sense, and at some point not. This is where you have to be honest and to don't sell additive manufacturing in the market and nobody can use it at the end. This is, I hopefully think the market learns from the past. In my opinion, the only way to go in an industrialization of additive manufacturing.
Yeah, makes sense. I mean, that is the reality of AM. Another tool in the toolbox. You hear that term used a lot, but it is. I mean, there's many options to obviously build and manufacture. The benefits of AM have their own place and time, and just like every other manufacturing method. But that is, talking about the reality of that. It doesn't solve all the problems, but there are specific problems it can solve, and you want to use it during that time. And so great to bring up that point. The reality is a big deal, and I think that's why it's important companies like you that are actually doing the big picture, not just printing something on the machine, but using it in a process and then improving that process with the customer, because that's where it doesn't just sit still and not be used. It's something that's an available part of a process that's integrated into your manufacturing process, and that's where the strength is. Not just leaving somebody alone with the machine and hoping that they could print something well.
Absolutely.
So really cool to hear all that, Michael, and great to talk to you today. And I want to wish you well and look forward to chatting again. Thank you so much for joining us.
Thank you.